In this lesson, we're going to be going over some linear equation word problems. So we'll be building off of what we had done in the previous lesson. And before we start, I just want to stress with word problems, the I can't stress enough the key is that we need to make sure that we're reading the problem and understanding exactly what it's asking and what it's asking us to solve for. That's going to be the biggest part, that we get the equation itself set up properly with what it's asking, because the math itself isn't going to be overly hard. Once we get to that point, it should be fairly easy and straightforward. But the key is just making sure we have the equations set up right, because if that's off, if we're not sure what it's actually asking for and the equation is wrong, well, then it won't matter if the math is right. So that'll be our key going forward for all of these, but let's get started. So the first one is asking, so we have when 70% of a number is added to the number, the result is 204. What is the number? So it's asking us, there are a couple things that I would do right away. I mean, it's asking us what is the number? So we can assign a variable right away. Let's just make it, and that'll be pretty much my general go-to for all of these. Just do x. Make it easy, make it simple. So what is the number? So we'll call that x. So that is what we're trying to solve for, whatever this number is. And then it's telling us the result is 204. So we could, sorry, take care of that. All right, so we could start off our equation right now and set it equal to 204. All right, so we know a couple things right off the bat. We know what we're looking for, the number is going to be, we're calling that x, and then we can set our equation. We know it's equal to 204. So now let's see what we have up front here. We have when 70% of a number, which again we're saying is x, is added to the number, so that's the same number, x. Okay, so let's start off with the front half. So we're saying when 70% of a number, our number x that we're trying to figure out. Well, if we want to know what 70% of a number is, how can we figure that out? Like if we wanted to figure out what 70% of 50 is, how would we put that into our calculator? We would just do, in this case, take 50 and then multiply it times 0.7, in which case that would give us 35. So let's plug that in over here. So we're asking when 70% of a number, this number x, so we're going to have to take whatever our number x is and multiply it times 0.7. And that it's saying is added to the number, this same number, so when it is added to the number, we will get 204. All right, so let's go back in, let's check our equation. All right, let's see if it matches up with what they're asking. So they're saying when 70% of a number, which is what we have here, is added to this number, the result is 204. So it looks like everything matches up with what the problem is asking. So we'll clean this up a bit here. So we have, and we'll just get rid of the parentheses. So let's just clear that out. So we have 0.70x plus x equals 204. And now it's just math to solve for x, whatever, trying to figure out what this number is. So what's 0.7x plus x? So that would just be like adding 0.7 plus 1. So we'd have 1.7x equals 204. And then to solve for x, all we have to do is divide out the 1.7 on both sides. So it looks like x in this case comes out to 120. X is equal to 120. So what is the number? The number is 120. And of course, we know that we can always check ourselves if we took 0.7 times 120, that's equal to 84, and then add that to 120, and that does indeed come out to 204. So it looks like we are correct here in saying that the number in this case is 120. All right, let's move on to the next one. Okay, so the next one is asking when 5 times the number is added to 8 times the number, the result is 78. What is the number? So again, it's asking what is the number. Let's call that x again. Okay. And again, we have right here, we can plug that in because it's saying the result is 78, so we can put that in right away. All right, now let's fill out the left side of the equation. So let's start at the front half when 5 times the number. So we know the number is, we're saying is x. This mystery number is x when 5 times that number. So put a 5 out front. 5x is added to 8 times the number. So now this will be 8x. Whatever the number is, 8 times that when it's added to. Our total result will be 78. All right, so let's go through. We have it set up. Let's read through it one more time just to be safe. So we have when 5 times the number x is added to 8 times the number x, the result is 78. All right, so everything matches up. Everything looks good here. And this one is pretty simple for us. So we have like terms here, 5x and 8x. So 5 plus 8 will give us 13x equal to 78. And then we just have to divide out 13. That, of course, cancels, and we're left with x is equal to 70 divided by 13 is 6. So our final answer for this one, the number is 6. And we check here, we have 5 times 6, that's 30, plus 8 times 6 is 48, and that indeed is equal to 78. So everything matches up, that looks good. So 6 is our answer for that one. All right, we'll move on to the next one. This one will probably be a little more difficult for most people. But again, this one, we just got to read it over. It's going to be all about the setup. All right, so it's telling us that during a road trip, Jason drove 1/3 the distance that Anna drove. Michael drives 24 more miles than Anna drove. The total distance they drove on the road trip was 680 miles. How many miles did Michael drive? All right, well, I'll do blue this time. All right, let's look at highlight some key parts here. So we have, how many miles did Michael drive? Right, so that's what they're asking us to find. So like we've been doing, let's make that our x variable. So we're trying to solve for x, which is how many miles did Michael drive? Okay, and then they tell us Michael drove 24 more miles than Anna drove. Okay, and then Jason drove 1/3 the distance that Anna drove. Well, let's throw in like we've been doing. It tells us the total distance we have Jason, Michael, and Anna. Between the three of them, looks like the total distance they drove was 680 miles. So again, we got the right side of our equation. So we just need to get the left set up. So let's write out, we have 3 people. So we have Jason, and then we have Anna, and we have Michael. Okay. Well, let's start with Michael because we know he's just X. Michael is just X because that's what we're trying to solve for. Okay, so let's backtrack. So we got the 680. We got Michael as X. Now here it's telling us we can figure out what Anna is because it's telling us that Michael drove 24 more miles than Anna drove. So whatever, for Anna, in her case, whatever Michael drove, Anna drove 24 fewer miles. Okay? Whatever, Michael drove 24 more miles, so Anna had to have driven then. She drove whatever Michael drove, subtract 24 miles, and then that's what Anna drove. So we're kind of backtracking here. So we got Michael, we got Anna, both in terms of X. So let's see what we can do about Jason. And it says Jason drove 1/3 the distance that Anna drove. Well, we just figured out, we just said Anna is equal to X minus 24. So all we're saying for Jason is that he drove 1/3 that distance. He drove 1/3 the distance that Anna drove. And Anna, we said, is going to be equal to X minus 24. So that must be Jason's total mileage. So essentially with this problem, we were able to work backwards and we were able to put everything in terms of x. What we're trying to solve for, Michael, we're trying to solve for him. We know the total distance was 680 miles. And then backtracked, we were able to figure out Anna based off of Michael, and then we were able to figure out Jason based off of Anna. So we have everything set up. We have all three of them, and we know their total 680 miles. All right, so let's get this set up here. So we'll have 1/3 x minus 24. That's Jason. Anna. And then we have Mike. All right, everything looks good. We have our equations set up. All three of them are accounted for. So now we can go about solving for our x variable. So let's start with, let's definitely, first step should be get rid of these parentheses. So if we distribute the 1/3 times x, that'll get us to 1/3 x minus, and then what's 1/3 times 24? That would just be 8, and then plus x minus 24 plus x equals 680. Okay, now let's combine some like terms. I think I'm going to do the x first. So we have 1x, we have 2x plus another third. So it looks like we have 2 and 1/3 x. Okay, and then we can get the ones without the x knocked out too in this same shot here. So we have -8 minus 24. So -8 minus 24 will get us -32. So we've combined our like terms now. Okay, let's move our screen down. Okay. And then I think what I'm going to do next, and it's just a personal preference, I think I'm going to, instead of having the compound fraction, I'm going to make that into an improper fraction. And in case you're not aware, the way we do that is so that it's not a mixed fraction like this. I'm going to make it an improper fraction where the numerator is bigger than the denominator is all. But all we do is we take the denominator times the whole number and then add the numerator, and then it's over the denominator. So 3 times 2 plus 1. So we get 7, and then over our denominator, which is 3. So 2 and 1/3 is the same thing as saying 7/3. I just prefer to have it like that, especially when, just make it a little easier for putting it into the calculator when we have to divide out coming up here. So we'll have, let's add the 32 over. Okay, so 680 plus 32, so that's 712. And this is equal to 7/3 x, and then we just divide by 7/3 on both sides. And when we do that, x comes out to, should be 305, and this will be in miles. as our unit, 305 miles, and I think it came out to just slightly above, so we're rounding off to the nearest mile. So 305 miles, that is how many miles that Michael drove in this case. All right, let's move on to the next one. And this is another one that tends to give some people problems. Get it set up properly and really figure out what it's asking, we should be just fine. So $15,000 with the stipulation that for the first year, money must be invested in two stocks, one paying 5% and one paying 10% annual interest. How much should be invested in the stock that pays 10% annual interest if the total interest earned for the year is going to be $800? First things first, we're going to need, for this one, a simple interest formula, which is just, put it down here, we have I equals P R T. Interest equals principal times rate times time. So we're going to need to know that for this problem. And of note, don't forget that whenever, in this case we have 5% and 10%, whenever you're plugging in for rate, you need to make sure that rate is always in decimal form. So just something to keep in mind. All right, and then I'm going to, just so we have a small little visualization of what it's asking. So we're inheriting 15,000, and then for the first year, that money, all of that 15,000 is being divvied up between two stocks, one that pays 5% and one that pays 10%. And then at the end of the year, between those two stocks, we made $800 in total interest. All right. So if it helps to see it like that, as opposed to the wordage, that is what it's asking. And we specifically need to figure out, all right, of that 15,000, how much was put into this stock in order to hit this $800 interest number. So let's make that our variable. So x is going to be the amount invested in the 10% stock. Okay? But we do have to remember, because there's two stocks, this is a combined effort to get to 800. So we have to account for both stocks when we're setting up our equation to get this 800 number. So let's do this one in blue. So if we know we invested all of the 15,000, so if X is what we put into the 10% stock, well then it would stand to reason that whatever is left over, 15,000 minus whatever this was, that has to be what we put into the other stock. So 15,000 minus x, whatever's left over, will be the amount invested in the 5% stock. So now, kind of like we saw with the last one, we have this also in terms of x. So now let's get our equation set up. And just so it's more clear to see, I'm first going to break it up so that we can visualize it better. So if we have, so again, so that's our 10% account. So now we'll be using our simple interest formula. So we have I is equal to X, which is what we're trying to figure out, because we don't know the principal, we don't know how much was put into that specific stock. So we have X times the rate for this one is the 10%, decimal form, and then our time is, it tells us here for the first year. So we're just dealing with 1 year's time. Let's get the 5% one set up. Be the same thing. So we have I equals, and then now this is 15,000 minus X, and then the rate is 5%, and the time, of course, is the same, 1 year. And then between these two, this is where we get the 800, which is our I. So now we're going to set this up. We'll be taking this part of the equation plus this part of the equation and setting it equal to 800. Let's get some more space here. Okay. So we'll have x times 0.10 times 1 plus 15,000 minus x times 0.05 times 1, all equal to $800. And let's go about solving this. But before, if you need to, of course, take a second to pause to make sure you have a grasp of how we got to this point. If you need to go back and figure out exactly how we got to this point before you go about solving it. All right, so now let's get rid of our parentheses. So, I mean, 0.1 times 1, so that's just still 0.1 times x would just be 0.10x, and then plus, when we multiply these out, of course, that just stays 0.05, and then let's distribute right away. So we'll have 0.05, and then we'll have to take it times the 15,000, and then times the x. So 0.05 times 15,000, that comes out to 750. And then minus 0.05 times x, just 0.05x, equals 800. And now let's combine like terms here. We have 0.10x minus 0.05, so that will just simplify to 0.05x plus 750 equals 800, and then subtract the 750. So we have 0.05x equals 50, and then divide out the 0.05, and it looks like x will be equal to 1,000. So this 1,000, that is so that will be the amount invested at 10%, which is what the question was asking us to find. Now, of course, if it wanted to know what was in the other one as well, then of course we would just figure out the difference, 15,000 minus 1,000. So that means if 1,000 was invested in the 10% stock, then of course we would have had to invest 14,000 in the 5% stock. So that's how we tackle that one. So let's move on to something that is, this one be a little more straightforward. All right, so we have a rectangular pool in this case. Well, let's definitely start out with, let's throw a drawing up here. So it's telling us that the length of a rectangular pool, so we're dealing with the long side here, the length is 5 meters less than twice the width. If the pool's perimeter is 134 meters, what are its dimensions? Okay. So once again, we can start off with, we have the right side of our equation. So we know it has to be, total perimeter is 134 meters. And then it's telling us that it doesn't specify anything specifically about the width. So let's just call that, well, we'll go W this time. W for width. We'll switch it up. So it doesn't specify anything about that, so we'll just call that W, but it does tell us a little something about the length. It's telling us that it's 5 meters less than twice the width. And the way I like to do, when it gives something like that, I kind of do the little equation, do it right to left. So it's saying the length is 5 meters less, so minus 5, then twice the width, W. So the length of a rectangular pool is 5 meters less than twice the width. So it looks like then perhaps that would be this side as well. So those are our dimensions, and we just need to figure out what some exact numbers. And if we're talking perimeter of a rectangle, all we're doing is taking, so we'll be taking W plus W, the width of both sides, plus both lengths, and adding everything together. So let's do some like terms here. So we have 1W, 2W, 4W, and 6W. So we have 6W, and then we have minus 5, so we have -5, -5, -5, -5. So that's going to come out to -10. So all of our like terms are combined. We have it simplified. Equals 134, and then if we add the 10, we're left with 6W equals, that'd be 144, and divide by 6. So W, our width, is equal to 24. And our unit here is, we're dealing with meters. So the width is 24 meters. So we have 24 meters, which would tell us then that if we plug in to what we had here for the length, if the width is 24 meters, well, 24 times 2, that's 48, minus 5, come out to 43 meters for the length. And we can always check ourselves if we have 43 times 2, that's 86, plus 24 times 2, 24 times 2, that's 48, and 86 plus 48 is indeed 134 meters for our perimeter. So this looks good here. Our answer, well, I guess it was looking for the dimensions, so this will be our answer here. Dimensions are 43 by 24 meters for this pool. All right, we have one more that I wanted to do, just slightly different. So we're going to solve for formula. It's going to be A equals 1/2 H A plus B. So A equals 1/2 H A plus B, and we are going to solve for A. So I just wanted you guys to see one where we're solving just for a variable and not trying to obtain an actual numerical value. Just see something a little different. So let's start off with, first step, let's get rid of these fractions here. So we'll have A equals, and then this is all one piece right here, 1/2 H. So we're just literally taking 1/2 H times A. So all that happens is just the A just gets tacked right on. That's all that happens here. Plus, and then distribute, take that times the B as well, and it'll be the same thing, just with B on the end. So 1/2 H times B will get us 1/2 HB. All right, so the fractions are gone, so now, or excuse me, the parentheses are gone, so now let's get rid of the fractions. So like we learned before, this is where we're going to have to apply the LCD. And in this case, we have 2 and 2 in our denominator, so the LCD is just going to be 2 in order to get rid of those fractions. So we'll be taking 2, remember, times everything, each piece, so 2 times A, and then 2 times 2 times that, and 2 times So over on the left side, of course, that'll just become 2a. And then here, again, we get our cancellation because we have a 2 in the top and the bottom numerator and their denominator. Again, if you think of this like 2 over 1. So these will cancel. So we're just left with, we have on the top, we have 1 times HA, which is just HA divided by 1, not changing anything. So all we have left is just HA. And then same thing here. The 2's will cancel, and we're just left with HB times 1 divided by 1. That's not changing the HB at all. All that's left is the HB. Okay. And then here, again, we're solving for, we want to solve for A. So let's work on isolating that, and just like we would have normally done, again, just because it's letters instead of numbers, don't let it throw you off. We're literally just subtracting HB from both sides. So now we have 2A minus HB equals HA. And then, again, don't let it throw you off. What would be the last thing we'd have to do to isolate A? Simply divide out the H on both sides. Those cancel, so we're left with A is equal to 2A minus HB over H. And careful with the H's here, because they wouldn't cancel because this H is attached to the B. That's one piece right there. So that the H's wouldn't cancel in that instance. If the H was by itself, separate from the B, then we could, but because it's attached to the B, the H's won't cancel, so we still have we're still dividing by the H. So that is our final answer, just solving no numbers, just strictly solving for a letter variable. A equals 2A minus HB over H. And all right, that does it for this lesson. Hope it was helpful again, and thank you for watching. Be sure to check out the channel for more algebra lessons as they come up.